So let me just show you how polynomial long division works, why we use it, and then how we convert this to something called synthetic division. Synthetic division is, I think, an easier process, but it's only used in specific kinds of polynomial long division. So if I asked you to take, sorry, scratch that. 3x cubed plus 5x squared plus 8x plus 7 and divide by 3x plus 2. Okay, so division is really the reverse of multiplication, right? Agreed? So I could say, instead of dividing, I'm trying to figure out what I can multiply this by to get this. So, in fact, when you did long division in 5th grade, you would do that. You'd say, okay, if there were multiple digits, and you'd cover them up and you'd say, what, this times what gives you that? So 3x times what would give you 3x cubed? Okay. So what we do is we're going to just take the first term and we're going to figure out what multiplies by that term to give us this term, and then we need to below multiply x squared by this entire binomial. So x squared times 3x is 3x cubed. X squared times 2 is plus 2x squared. What would come next in long division then? Normally you would subtract the expression, and we're going to do that here. Please don't forget, though, we got to subtract both numbers. So what's 3x cubed minus 3x cubed? Good. 5x squared minus 2x squared is 3x squared. And then we bring down the next term. This is how long division would have worked with regular numbers as well. Okay. So now we keep going, basically until we get either it finishes with no remainder or we get a remainder. So now I have to figure out 3x times what gives me 3x squared? X. So x times 3x is 3x squared. And then x times 2 is plus 2x. And then we subtract. Okay, so what is 8x minus 2x? I'm ignoring this because this is 0, correct? 3x squared. 6x, and then I'd bring down the plus 7. Alright, 3x, does 3x go into 6x? Yep. Plus 2. So 2 times 3x is 6x. 2 times 2 is 4. Okay, so now we have 3, and 3 is considered our remainder. So let's go through what the different parts are. This we call the divisor. this part up top would be called the quotient, because that's what I get. That was the result I got when I divided the two. Underneath the division, that's called the dividend. And this is called remainder. And basically what's going on here is, if I wanted to make sense of this whole statement, what this means is if I took 3x plus 2 and I multiplied it by x squared plus x plus 2, and then I added on 3, okay, that's if I did this times this and then I added on 3, I would get 3x cubed plus 5x squared plus 8x plus 7. This is called a summary statement. Basically, what's going on here. When I divided this by this, I got that, and then plus that as a remainder. Okay. So, what does it mean if I get a remainder of 0 in polynomial? What do you remember about that? It does. And what that would mean is, like, if you look here, doesn't this almost look like something factored? Okay? If it had a remainder of 0, haven't I just found a way to factor it, really? And think about zero product property. If I found a way to factor it, haven't I also just found a 0? So, something to make sure we're watching out for when we do division. I'm going to say remainders and factors. Is this. If a polynomial f of x is divided by x minus k, then two things. First of all, I could find the remainder by just taking f of k, whatever that number was. So if a polynomial f of x is divided by x minus k, then the remainder is f of k. And then furthermore, if f of k equals 0, then x minus k is a factor. That was just an example of how long division works. Okay. 3x plus 2 would not be a factor, right? What's that? Will it always be, what do you mean by even? Yeah. Yeah. Today it will. Later on, we will look at the graph and we'll say, hey, it looks like 2 is a 0. If 2 is a 0, x minus 2 is a factor. Let's divide it off and see what happens. So we will, but for today, we're just going to review synthetic division. So it will be given to you. All right. I'm going to show you a minute then how synthetic division works. Do you guys remember, anybody remember anything about synthetic division, putting the number in the corner in the box? Okay. You spent several days on it last year. If you were in Mr. Stoblin's class anyway. So, I'm going to give you an example, and I'm going to show you how it works with synthetic division, and then I'm going to show you, or how it would be set up with long division and then synthetic. So, if I said, let's take 2x cubed minus 3x squared minus 5x minus 12, and we're going to divide by x minus 3. Excuse me. All right, so let's go through and what would go up here then? What would I put up here first? 2x squared, good. 2x squared times x is 2x cubed. 2x squared times negative 3 is minus 6x squared. Then I subtract. Be careful here, this is minus a negative 6x, okay? So that becomes then positive 3x squared minus 5x. Okay, what would come next? Good. So 3x times x is 3x squared. 3x times negative 3 is minus 9x. Subtract the quantity. So this is negative 5x plus 9x, which is 4x minus 12. And finally, plus 4. So we have 4x minus 12. Ooh. What do we have? Okay. Remainder of 0. When we're all done with synthetic, I'll show you graphically what that means. What we really have found then is we found a factor of it. We found a factor of 2x cubed. Okay, so here's how synthetic division works. If you're dividing x minus 3, you actually put 3 in a box in the corner here. So I am going to rewrite the same one we did with long division with synthetic division.